Hi everyone and welcome back to PrepFusion. I'm Anish and today we will solve the assignment questions that I gave you as homework in the previous lecture. So this was the first question I believe, like except this, like all the previous question had already been solved. So we will solve this question. So in this question, like this is a very good question. So H parameter of a two-port network containing only resistive elements is shown. So the network only contains resistive elements, okay, shown below. And like something is written that at t equal to 0 we are closing the switch and initially the voltage across the capacitor is 5 volts vc0 minus and capacitance is 2 farad and this is 2 ohms. Okay, now what are they telling? Find out the value of this voltage across the capacitor at t equals to 1 second. So what is v of c if the initial if few other initial conditions are also given? Okay, so remember we have learned about H parameters. So H parameters are also applicable for an instant as well. So any parameters for a matter of fact. So any two port parameter will be applicable for a instant as well. So basically if I have this H parameter, what is the H parameter? What are the dependent variables of H parameter? I remember I used to write V1. Then again, if I have written here V1, I will not be able to write here V1, right? So I have to write something else. I have to write I1. So I will write here I1. And of course, if I have written V1, if I have written I1, only either I2 or V2 can be there. Obviously, it is a hybrid parameter. So one current is there. So there will be another voltage. So this will be V2. Now, this will be H11 plus H12. Here I have, now of course, what is the other dependent variable? I2. I2 will be with H21 into I1 plus H22 into I2 into V2. So this, right, is general equation. This can be applied at an instant as well. What do you mean by instant? Basically the instantaneous relation should also be valid. So basically I can write here V1 of t will be equals to H11. So instantaneous, right, we generally write in small letters. So this will be small v1 of t into I1 of t plus H12 V2 of t I2 of t into H21 IN of t into H22 V2 of t. Okay, so these are the parameters basically. I will use this, right? So first of all, it contains only resistive elements. So this whole thing and on the right hand side contains only resistive elements. So can I redraw my circuit like this? Because in the question they have told me it contains only resistive elements. So my circuit, right, can be redrawn like this, R equivalent and C here, okay, because I know it contains only resistive elements, correct? It contains only resistive elements, so of course I can convert the whole resistor, whole or whatever is there on the right hand side into a equivalent resistance. So it will be here, switch is here at t equal to 0 and initial voltage across the capacitor is Vc0 minus is 2 volts, I guess it is 5 volts. Okay, so after closing the switch, what will happen? I know you have studied transient, right? I know you have studied transient. After closing the switch, what will happen? Instantly a current will be generated, that is 5 divided by R equivalent, and that will flow throughout the resistor and a drop will happen and the capacitor will discharge through the resistor. So what is the initial value of the voltage? So initial value of the voltage is Vc0 plus will be 5 volts, right? Because capacitor will not change its voltage instantaneously. After closing the switch, capacitor voltage will be constant. So this is simple transient, right? Simple transient. So then what will happen is that it will go down to 0. So the equation of Vc of t will be 5 e raised to power minus t upon tau, where tau is C into R equivalent. I don't know what is R equivalent. I don't know what is R equivalent. I will discuss. I will discuss about the R equivalent later on. Okay. So this is the like equation of the voltage. So I have to find out Vc of t at t equal to 1 second. So I have to put here 1. So if I put here 1, Vc of 1, this will be 5 e raised to power minus 1 by tau. Okay. So this is what my Vc of 1 will be equals to. Now I don't know what is tau. So for tau, right, I have to go back to this equation. For tau, I have to go back to this equation or here. Okay. So what is R equivalent? Can you tell me what is R equivalent? R equivalent is actually, if I just copy this voltage, if I just copy this circuit, R equivalent is the impedance or the resistance seen from this port 1. Okay. So it is basically that if I apply a voltage source here and measure the current, and it is unconditional, right? It is unconditional. There is no condition like either I2 will be 0 or V1 will be 0, nothing like that. It is unconditional. So it is V1 by I1 without any condition. So we will be able to find out unconditional input impedance, because I have told you, right, if resistance is connected or something, then we are able to find out the unconditional impedances. So exactly that is what we will do here. So I will write the H parameters basically. I will copy this H parameter here. Okay. So first of all, again the same thing whatever we have learned. So my V2 will be equals to minus I2 into 2R minus I2 of t, V2 of t, instantaneous voltage V2 of t, into minus I2 into 2. Like this I hope there is no doubt in how this negative sign came. This we have done multiple times in the previous lecture. So there should not be any doubt how this negative sign came. Okay. Now what can I do is I can replace this in the equation. So first let me write down the each parameter. So this is V1 equals to 1 into I1 plus 2 into V2 and I2 equals to minus 2 into I1 into H22 into V2. So H22 into V2 is 2V2. Okay. So this will be what? This will be I2 will be this. So now, right, now I will replace my V2 with 2I minus 2I2. So this will be I2 equals to minus 2I1 plus 2 into minus 2 I2. So it will be 5 I2 equals to minus 2 I1, or I2 equals to minus 2 by 5 I1. So now I will replace this okay, no. I2 I have got. Okay, what I can do is I can replace the V2, right? So V2 equals to minus 2 I2. So V2 equals to 4 by 5 I1, because it is equals to minus 2 I2. So I will replace this V2 in this equation. So I will get the ratio of V1 by I1. So V1 will be equals to I1 plus 2 into V2. 2 into V2 is 4 by 5 I1. So from here I can easily get the R equivalent. Okay, from here I can easily get the R equivalent. What will be my R equivalent? So my R equivalent from here, this will be 8 by 5 and V1 equals to 8 by 5. So this will be 13 by 5 I1 and V1 by I1 is equals to 13 by 5. Okay, from here this is my R equivalent. So ultimately my tau will be R equivalent into C. What is R equivalent? R equivalent is this value and C is 2 farad. So it will be 26 by 5. Okay, so basically, right, basically this we have found out R equivalent. So now I can simply find the value of voltage. So what will be the voltage? Voltage Vc of t is very simple. So it will be 5 e raised to power minus 1 divided by tau, that is 26 by 5. Okay, so this will be equals to, I will just quickly calculate this value. So this value will be 5 divided by 26 e raised to power negative into 5. So this will be around 4.12 volts. So 4.12 volts will be the answer of this question. So you don't even need that extra information, right? You don't even need this extra information, all this information, right? Do you need this information? Okay, just hold on. H11 is there. Yeah, anyways you don't need, that information. No, you don't need that information. No. So all this, right, this I2 of 0, this I1 of 0, these are not required actually. So these are just there to trick you. So I will actually remove this information, maybe. Yeah, maybe because if I keep this information, right, there can be something wrong in the question. So let's remove the information in the assignment question as well. I will remove the information because there can be a bit of confusion. Yeah, because the equations can come differently. So yeah, I hope you have enjoyed. Like just check if my calculation is correct. If there is something wrong, I most probably have done everything correctly only. So I'll just quickly calculate this again. So they're asking me to find out the voltage at t equals to 1 second. So equation will be like, this whole thing can be converted into a single resistance R equivalent. Okay, because it will be some combination, series or parallel combination of resistance. So this whole thing will be combined to R equivalent. So the circuit is this one, and the equation of the voltage will be 5 e raised to power minus t upon tau. T is 1 seconds, tau is C into R equivalent. So what is R equivalent? For finding out R equivalent, basically I have to find out the ratio of V1 by I1 without any condition. So I write the each parameter equation. So each parameter, here it is 1, here it is 2, here it is minus 2, here it is 2. Okay, next my V2 is minus 2 I2. V2 is minus 2 I2, so I replace here with minus 2 I2. So this will be minus 4 I2. This will go at that side. This will be 4 5 5 I2. 5 I2 will be here. So this will be I2 equals to minus 2 by 5 I1. So and V2 is minus 2 into I2. So I will multiply minus 2 with this. So this will be 4 by 5 I1. Okay, V2 will be 4 by 5 I1. So V1 will be equals to I1 plus 2 4 by 5 I1, right? Because here I have 2 4 by 5 I1. So this will be I1 plus 8 by 5 I1. So this will be yeah, 5. If I add a 5 here, so this will be 13 by 5 I1 V1. Okay, so V1 by I1 will be equals to 13 by 5. V1 by I1 will be equals to 13 by 5. That is equals to my R equivalent. Okay, that is equals to my R equivalent. So tau is equals to my R equivalent into C, and R equivalent is 13 by 5 and C is 2, so it will be 26 by 5. So if I replace this, yeah, everything is correct. So this will be the answer of this question, 4.12 volts. So this question is very very beautiful, and I'm expecting something like this to get us, right? Because they have not yet mixed the transient and the two ports. Someday they will mix, and trust me, like many educators, they will give you some lengthy solution and all those things, right? So it is not that lengthy. If you know transient very well, it should not be that lengthy. Okay, so yeah, that's basically it for this question. Let's now move on to the next one, right? Let's now move on to the next question. So in the next question, this was already done. This one I gave you homework. Okay, so let's find out the H11 parameter. So if they have asked you to find out the individual parameter, right, you will not solve the whole network. So you will just do the condition, and just look at this. They have even given you the what is your H11. They have even given you what is your H11 V1 by A1. Also they have given you this. Okay, so you don't have to remember it, right? So basically they have already given you. So but of course, if you tend to forget how to remember it, I have already told you. So we have to find out H11 where my V2 is short circuited. So if my V2 is short circuited, so I'll short circuit my V2. So V2 is short circuited here, okay, and I have to find out V1 by I1. So I1 is this, so this is 2I1, and here, right, I have two branches, like this one is also going here, this one is also going here, both have same potential, right? This is the same node, this is grounded, so this point is grounded. So if I assume here some potential V, okay, I can assume here some potential V. If I assume a potential V over here, this will be V by 1, V by 1. So if I can apply a KCL at this node. If I apply KCL at this node, basically I will have minus I1 incoming plus 2I1 outgoing plus, okay, my eraser is really bad, plus 2I1 plus V by 1 plus V by 1, okay, equals to 0. So from here I can directly find out what is the value of V. So V will be equals to minus of I1, sorry, minus of I1 divided by 2. So this is 2V, that will go on that, minus of I1 divided by 2. So that is what my V is equals to. That is what my V is equals to, minus of I1 divided by 2. But I have to write in terms of V1. So I can apply a KVL here, right? I can apply a simple KVL here. If I apply KVL, minus of V1 will be plus I1 into 1 plus V. This is the voltage V, right? Equal to 0. So V is minus I1 divided by 2. So V1 equals to I1 divided by 2. So V1 by I1 will be half. Okay, like these kind of easy questions come. So it will be 0.5. So I have taught you the difficult level, like highest level of problems. Gate POIQs will be just like a cakewalk for you. Okay, so this was the method 1 where we use the simple KVL and KCL. What is the other method? Other method is using source transformation. Okay, you can use source transformation. So method 2 is the one where you can use transformation. So in source transformation, basically what I will do, I will convert this parallel current source, like this current source, right, into a series combination of a voltage source. So the left hand side will be same only. This will be 1 ohm. This will be 1 ohm. I guess, yes. And the right hand side will, this will become 1 ohm, and this will be the voltage source, 2I1 into the resistance, that is 1 only. Okay, that's not matter, it is 1, so it will not matter. So now you can easily find it out in one shot. So this is your V1, okay, this is your current I1, V2 is 0, and this is your current I2, but it won't matter basically. So here, right, I have I1 current incoming, this is I2 current incoming, so this will be I1 plus I2, or I can write a KVL here and I can write a KVL here. That will solve. I will write two KVLs. I will write a KVL here. I will write, okay, I can write KVL here. I can write a KVL here. Okay, this will also solve a problem. So I can write a KVL here. I can write a KVL here. Okay, so the first KVL will be minus V1 plus I1 into 1 plus, this is what, I1 plus I2. This current is what, I1 plus I2. I1 plus I2 into 1 equal to 0. So V1 will be equals to 2I1 plus I2. Okay, and what about the output KVL? This was the KVL 1. KVL 2. Okay, and this will be plus 2I1 plus the current drop is I2 into 1 I2 into 1 plus I1 plus I2 into 1 equal to 0. So from here I can find out the relationship between I2 and I1. So I2, this is 2I2 or 4I2 equals to minus 2I1, not minus 2, is it minus 2? Here I have 1, okay, this is 2I1. How is this 2I1? Oh, that is due to that, right? Okay, yeah, okay. So I2 will be equals to minus I1 by 2, that we found out from the uh, previous one as well, right? So from here I can directly replace my I2 and I1. Okay, anything, am I doing anything wrong? Okay, sorry, this will not be 2, right? This will be 3 because I have a I1 here as well. So this will be 3 by, oh, 2 only, this will be 2, right? So this will be 3 by 2 I2, sorry, 3 by 2 I1. So I will replace it over here. If I replace here, right, so basically what I will get is V1 will be equals to 2I1 minus 3 by 2 I1. So V1 will be equals to, this will be 4, that is I1. If I multiply 2 here, 4 minus divided by 2, yeah, I1 divided by 2. So from here as well you get the ratio that your V1 by I1 is equals to 1 by 2 ohms. So yeah, from here you can write your answer, that is V1 by I1 equals to 1 by 2 ohms. So this will be the answer for this question. Let's move on to the next question. Next question is very interesting question. Okay, so what they have told you is that like there are many ways to solve this question, so we will try to reach to the best solution. So here a network is given, okay, and few conditions are given. If ammeter is closed, if it is open, and the values are given, right? The port voltages, port currents are given. They are asking us to find the Z parameter and the H parameter. So let's first discuss about the Z parameter. So what is the condition for Z parameter? So Z parameter, if you remember, are the open circuit parameter. Z parameter are the open circuit parameter where my V1 equals to I1 Z11 plus I2 Z12, V2 equals to I1 Z21 plus I2 Z22. Okay, so now what I can say is, if I, like they are open circuit parameters, right? Basically either I make I1 equal to 0 or I make I2 equal to 0. And ammeters, if you remember, are connected with series as the current ports and the voltmeter are connected in parallel. So whenever the ammeters current through the ammeter is 0, that means I am very interested. I am very interested because that will be the condition for the Z parameters. So if I observe in the first case, switch S1 is open. If S1 is open, that means what? In the first case, if switch S1 is open, that means the current I1 will be 0. Of course, it is open circuited, so current I1 will be 0. So if I1 is 0, then the port current ammeter current through A1 is 0 because it is open circuit. V1 is 4.5 volts, V2 is 1.5 volts, and I2, the current through the ammeter to A2 is 1 ampere. Okay, so I can say that my Z11 equals to V1 by I1 when my I2 is 0. So from here I can, not I2, sorry, okay, Z11 I won't be able to find, but I will be able to find Z12, right? Will be equals to V1 by I2 when I1 is 0. So V1 divided by I2, if I do the ratio, it will be 4.5 ohms. So if I see Z12 is the second element, first row, second element. So 4.5 ohms is here, 4.5 ohms is here. So these are automatically cancelled, eliminated, right? Only these are the two possible answers. Now let's calculate the Z22. Z22 will be V2 by I2 when my I1 is 0 again. So V2 is 1.5 volts, I2 is 1 amperes, so it will be 1.5 volts divided by 1 amperes, so it will be 1.5 ohms. So the second row second element will be 1.5 ohms, second row second element, so this is 4.5, this is 1.5, so of course this one is again eliminated, only one option is left, option C will be correct. So let's cross verify, right? Let's cross verify. So when now the second case, right, what is the case 2? Case 2 is S2 is open. So if S2 is open, that means my I2 current is 0. If S2 is open now, so in the case S2 is open, that means my I2 current will be 0. Okay, that means my I2 current will be 0. So what are the like values? So my current through the ammeter A1 is 4 amperes, so I1 is 4 amperes and V1 is 6 volts and I2 is 0 ampere. So I2 is 0 and I1 is 4, and what is V2? V2 is sorry, V2 is 6 volts, V1 is also 6 volts. Okay, V2 is 6 volts, V1 is also 6 volts. So now if I find out the Z11, Z11 is what? V1 by I1 when I2 is 0. So it will be equals to V1 by I1, that is 6 by 4. So it will be 6 by 4. So it will be 1.5 ohms. And Z21 will be V2 by I1 when my I2 is equals to 0. So V2 by I1 will be equals to 6 divided by I1. Okay, I1 is 4. This will be equals to 1.5 ohms again. So the Z11 is 1.5, which is correct here. Z21 is 1.5, which is again correct. So of course this is the correct answer of this question. Now let's check for the part 2, right? Let's check for the part 2. Okay, so if I check for the part 2, the H parameter matrix for this network is here. Now what I can say is that so I have to find out the H parameter matrix. So what is the H parameter equations? What are the H parameter equations? So if I write the H parameter equations, so here first of all I write V1, then of course I cannot write V1 here, I have to write I1, and as it is a mixed combination of current and voltage, this will be V2. Okay, and then I will replace this with H11 plus H12, and same thing I will copy here. Here instead of V1 it will be I2. Okay, this will be H21 and H21 and H22. So from here I can directly find out what is my H11. H11 is V1 by I1 when V2 is 0. Okay, so actually I cannot directly find this one out. Okay, but few things I noticed is that my okay, it is not even reciprocal, right? Because H21 is not equals to minus of H12. Oh, sorry, it is reciprocal, right? It is, this network is reciprocal. What I noticed about the Z parameter, what is the Z parameter? So Z parameter, the Z parameter of this network so there are only two cases, right? Yeah, so the Z parameter of this network is 1.5, 4.5, 1.5, 4.5, 1.5, 1.5. So this will be what? My Z12 is equals to Z21. That means what? That means my network is reciprocal. So if network is reciprocal, right, what is the condition for H parameter? My determinant of H should be equals to 1. Sorry, no. it will be my h12 should be equals to minus of h21, right? Very small modification, h12 should be equals to minus of h21. That is the condition for reciprocal, correct? That is the condition for reciprocal. So it is not symmetrical, so determinant of h should not be because okay, it is symmetrical as well. Okay, sorry. Okay, what am I doing? Sorry. Z12 is not equal to Z21, right? It is not equal to Z21. So network is not reciprocal. Network is not reciprocal actually. Okay, Z12 is this, Z21 is this, right? It is not equal. So here this also will not be valid. This also will not be valid. Okay, because this was the reciprocity condition. But another condition is there, that my Z11 is equals to Z22. And what is this condition for? Symmetricity. So my network is symmetric actually. So if my network is symmetric in Z parameter, then what is the condition? Condition in H parameter, the determinant of H must be equals to 1. So I will check that, right? First of all, it should not be negative. So none of them, H21 is always like that condition is not satisfying anywhere. So yeah, all the options are, we cannot eliminate all the options. But let's find out the determinant of this. So this is minus of 1 and this is plus 3. This is to plus 2 determinant, not possible. Plus 2 determinant is not possible. Oh no, sorry, wait. What is the determinant of this matrix? Sorry, not minus of 1. This is 2 by 3, right? So this is minus of 2 plus 3. This is one determinant. Okay, fine. This is minus of 2 plus 3. This is also one determinant. This is not possible. This is plus of 2 minus 3. Not possible. This is determinant minus 1. Not possible. This is minus of 2 plus 3, again this is also possible. So all of them has determinant 1. Okay, all of them have determinant 1. So like A B D have determinant as 1. So these networks are symmetrical. These networks are symmetrical. But how do I solve it then? So one thing, you know, Z11, right? H11 I will not be able to find because there is a condition of V2 equal to 0 that is not given in the question. That is not given in the question. But what I know is I can find out the value of what I can find out the value of what I can find out 1 V2 is 0. Okay, I can find out the value of the other parameters like H12. What is H12? H12 is V1 by V2 when my current I1 is 0. So when my current I1 is 0, here my current I1 is 0, right? Here my current I1 is 0 in this case. So what is the ratio of V1 by V2? It is 3. V1 by V2 is 3. So this will be 3. So H12 will be 3. That is 100%. I am 100% sure about that. H12 will be 3. Okay. So wherever H12, the first row and second element is 3, those are my options. So this is automatically eliminated. So this and this are automatically eliminated. Only these are the two possible. Okay, sorry, not this as well. It should be 3, right? This is also eliminated. This is anyways eliminated because the determinant is not my 1. This is also eliminated because H12 must be 3. This is also eliminated because H12 must be 3. So only on this option H12 is 3. Let us verify it even further. Okay. So if I verify it even further, what I can determine is H22. H22 is I2 by V2 when my current I1 is 0. So again coming back to this condition, I2 upon V2. So I2 upon V2 is 1 upon 1.5. It is 1 upon 1.5. It will be 2 by 3. So this will be, it will be 3 by 2. So this will be 2 by 3. Or I can write this as 0.67. Okay. So yeah, 0.67 is the H22 value. 0.67 is the H22 value which is present over here, 0.67. So again these two values are matching. How do I verify these two values? For these two values you have to make V2 0. Okay. For these two values you have to make V2 0. How can you verify that? So there are two ways to go about it. Like what things you know? What things do you know? So you know the Z parameters, right? So if I write the Z parameters here, my V1 equals to 1.5 I1 plus 4.5 I2. My V2 is equals to 1.5 I1 plus 1.5 I2. Now from here directly I need the ratio of V1 and I1 when the V2 is 0. So I will make here V2 0. So what is the ratio of V1 by I1? So if I make for this case, right, I will take this equation V2, I will make it 0. 0 is equals to 1.5 I1 equals to 1.5, sorry, plus 1.5 I2. So I1 equals to minus I2, or I2 equals to minus I1. So I will replace this I2 here. Okay, so my V1, first equation V1 will be 1.5 I1 plus 4.5 into minus of I1. So this will be V1 will be equals to minus 3 I1. So V1 by I1 equals to minus of 3 ohms. Okay, and negative, it can happen, negative impedance can come. So H11 is minus 3. H11 is minus 3. So is that correct? Is that correct? H11 is minus 3. Yes, it is correct, right? What about H11 is minus 3? What about H21? So what is my H21? So H21 will be I2 upon I1 when my V2 is 0. So again, right, if V2 is 0, you make this condition 0. So of course from here I can directly find out the ratio of I2 upon I1. I2 upon I1 will be the minus 1. I2 upon I1 will be the ratio of minus 1. So again, if I see what is the Z, H21 element, right? H21 element here is minus 1. So of course option A will be correct answer for this question. 77 and 76, option C will be correct answer. So I hope you have understood, like you can do conversions. So whenever you have one parameter, let's say y parameter, and they are asking each parameter, just write down the equation and write down the conditions for the y parameters. Put those conditions in this previous equation, and from there you calculate the ratios, and you will be able to find out the y parameters or any other parameter for a fact of matter. Okay, you don't need to remember any conversion because there is a big conversion table. Okay, that is in the book of Alexander Sadiko. You don't need to remember that. This much is more than enough. Okay, so in the next lecture we will learn about interconnections of two-port networks and two-port networks for few miscellaneous circuits like transformer and generator, which we have seen, but ABCD parameter and each parameter we have not seen. So we will discuss about those topics. So I hope you have enjoyed this lecture. If you did, make sure to hit the like button and put a comment down below which portion you enjoyed the most, and I will meet you in the next lecture. Until then, happy learning.